True or false? Is the sum I equals 0 to 4 of I factorial equal to the sum of j equal 2 to 6 of parenthesis j minus 2 factorial? Really, the fastest way to see if this is true is to expand each of these sums and add them and see if we get the same value. On the left, we get, this is equal to 0 factorial because we're starting our index with 0, plus 1 factorial, plus 2 factorial, plus 3 factorial, plus 4 factorial. Now you recall 0 factorial and 1 factorial are defined to be equal to 1. So we have 1 plus 2 times 1, which is 2, 3 times 2 times 1 is 6, and 4 times 3 times 2 times 1 is 24. Add these numbers together, we get the sum 34. So the value of the left sum is 34. Let's see if that's the same as the value of the right sum. For this one, that is equal to parenthesis, let j equal 2 because we're starting with the index 2. 2 minus 2 parenthesis factorial, plus 3 minus 2 factorial, plus 4 minus 2 factorial, plus 5 minus 2 factorial, plus 6 minus 2 factorial. Now simplify inside the parenthesis. We get 0 factorial plus 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. Whoa, does that look familiar? That's exactly what we had on the left. Sure enough, this is 1 plus 1 plus 2 plus 6, which equals 34. So we saw before we even finished that these yes were going to be equal to each other. So the answer is true. They are equal. They sure look different, but they are equal. So let's compare these two summations and see if how we could start with the left side one and rewrite it as the equivalent right side form. So the left side one was I equals 0 to 4 of I factorial. So that says add the index factorial starting with 0 and adding until you get to the fourth term. Now, the right side was an index j that started with the number 2, not the number 0. So I can see right now something that's different about these two. One starts at 0, the other starts at 2. So let's say that you were given this question. Write the sum I equals 0 to 4 of the term I factorial as an equivalent summation starting with the index 2. So we'll make an adjustment to the left side to make it start the same place as the right side. Let's adjust the sum, the index, to start at 2 instead of starting at 0. Okay? Well, to do that, we're going to, look at the index at the bottom. It is I equals 0. So let's write this out. Let's write sum I equals 0 to 4. I factorial. The bottom, we want it to start with 2, so we're going to add 2 to the bottom, which means we're going to add 2 more to the top also to keep it balanced. And what are we going to do to the I? We're going to do the opposite of adding 2 here. We're going to subtract 2. So once again, what did we do? We added 2 to the bottom, bumped it up, which meant we had to bump the top number up 2 to keep it balanced. And if we added 2 to those two, the bottom and top numbers on the summation, we have to do the opposite and subtract 2 from the index. Another thing we'll do is change the index from I to j. Okay, let's write that result on the right-hand side. That's equal to the summation j equals 2. Now that's where we were starting according to the question. And sure enough, we bumped up the bottom to a 2. What's the top going to be? It was 4, but we bumped it up 2, so it'll be 6. And then we have to change the I inside the parenthesis. We have to subtract 2 from that I and rename the I j, so it'll be j minus 2 factorial. And there it is. We got exactly the same value on the left and the right side. And all we had to do was rewrite it to get these changes. Now let's see if we can do that again. It worked for us here where we changed the bottom index and did the same thing to the top index and then did the opposite thing to the index and the ace of I. Now you try. We're going to rewrite the following summation. Sum I equal, 7 to 12 of 3 times I minus 4. 3 times I minus 4. Okay. And that's going to be equal to the sum j equal 1. All right, stop right there. They want the index to start at 1. Ours is starting at 7. So I'm going to stop right there, and you think about what's it going to take. What do we have to do to the bottom index of our j? What do we have to, well, we did it already, but what did we do to get that? What do we have to do to the top where the 12 is? What do we have to do to the I index in the a sub I, the 3i minus 1? 4, 3i minus 4. And then pause, try to figure it out, and then come back and continue listening. Okay, here's the solution. To get 7 to be 1, we're going to subtract 6 from the bottom, which means we're going to subtract 6 from the top also. We're going to do the exact opposite to the index I. We are going to add 6 to that I in parentheses. So we get that equal to the sum j equal 1 to 6 of 3 parentheses I plus j plus 6 minus 4. And when you simplify that, the sum j equal 1 to 6, 3 times j plus 14 when you combine like terms. So what I just put a box around, that sum is equivalent to the one that we started with on the left side, where we make the proper adjustments on the top and bottom of the summation and remove the I and replace it with the change with the j and then add 6 there. Nice. Okay, you've got homework like that. You'll get a lot of practice.